Hello, Paul 251 students. We are going to talk today about Z-scores and using them to figure out probabilities of observing different values. So last week, we talked about the standard normal distribution, and I talked about it as plotting observed values that have been converted into Z-scores. And I was using this formula here where Z-scores were equal to an observed value X minus the mean over the standard deviation. And so when you plot Z-scores out on the standard normal distribution here, what we have on the x-axis with these Z-scores is basically how many standard deviations an observation falls from the mean. Once we have that information and we know certain properties about the standard normal distribution, we can then calculate probabilities that we will or will not observe a particular score out of the full range of the area under the curve. Now, this entire distribution, this entire area under the curve is 100%. So in terms of thinking about probabilities, this is a 1. Everything adds up to 100%. Every piece of data or every possible observation out there will fall under this standard normal distribution. So it's really trying to figure out of that 100%, which area of the curve falls into certain ranges. And when we did this last week, we talked about a couple key rules. The first was that about 60% of observations fall between plus and minus 1 Z-scores. So we have about a 68% chance of observing Z-scores between positive and negative 1. About 95% of observations fall between plus and minus 2 Z-scores. And then finally, about 99% of observations fall between plus and minus 3 Z-scores. So this made some of the pieces of the exercises and examples last week really easy because we could calculate a Z-score of 1 and then say, okay, about 68% of the observations will fall between plus and minus 1. Or we calculated a Z-score of -2 and said about 2.5% of observations are lower than that -2. But what would happen if we don't have such neat rounded Z-score numbers? How can we use these Z-scores to still figure out the probability of observing certain values if we have something like, say, a -0.25 or a positive 0.76? How do we figure out the conversion between those Z-scores and those probabilities? And that's what we're going to talk about in this video. And we're going to do this using an exercise. And this exercise appeared briefly as the bonus for last week's Z-score lookup, but I figured I'd walk you through it step by step today, showing you how certain probabilities and specific Z-scores work. So here we have some of the information about IQ test scores that I used in the exercise last week. We know that these test scores have a normal distribution. They have a mean of 100, that's what this mu is, and they have a standard deviation of 15. That's what that sigma is. So there's 2 questions that I'm gonna ask and solve in this exercise. First, what percentage of scores fall above 120, a score of 121? And then what percentage of scores will fall above a value of 105? So to answer these 2 questions, each one requires 2 steps. First is we need to calculate the Z-score associated with the value. So we need to figure out what Z-score is associated with a value of an IQ test score of 121, and then what is the Z-score associated with an IQ test score value of 105. Once we have those Z-scores, we go to step 2, where we use a specific lookup table and then find out what percentage of cases fall either above or below that specific Z-score value. So let's walk through this. So step 1, we calculate the Z-score associated with each value. And again, here's just our general lay of the land. We have our mu of 100, our standard deviation sigma of 15, the 2 x's that we need to calculate for are 121 and 105. I have over to the right here my formula for a Z-score, where we'll be subtracting x minus mu over standard deviation. So I do this for the first score of 121. So in my numerator, I have 121 minus 100, that's 21, divided by 15, and I get 1.4. I do this for my second value here, 105. So in my numerator, it's 105 minus 100 divided by 15, or 105 minus 100 is 5 divided by 15, and that is 0.33. And I just rounded that to 2 decimal points for ease. Next, we need to use a Z-score lookup table to find the percentage of cases that fall above or below a certain value. So if I want to figure out the percentage of scores that fall above 121, I need to go and figure out what percentage coincides with a 1.40 Z-score. So to do this, I'm going to use a lookup table that is on Blackboard. So here I'm getting out of PowerPoint, I'm going into our Blackboard. I have our week 12 materials folder, and here I have a document called a Z table. So I'm going to click on that, and I'm also going to click the option to open the Z table as a different tab. So here we have this Z-score lookup table. And what it's going to give you is for each value of Z, the percentage of cases that fall to the left, or in this case, that shaded area under the curve. And the way this works is this first column on the left has your Z-score to 1 decimal point, and then each additional column across has the second decimal point value, or the 100th place decimal value. So for instance, this value of 0.0003 coincides with a Z-score of negative 3.40. And then this one would be negative 3.41, 3.42, 3.43, etc. across the row. So for the value of 121, we calculated that its Z-score is 1.4. And for the purposes of this table, we are gonna round to the 100th place, so that'll be 1.40. So I'm just gonna scroll down, get here to page 2, and here we are. Here's a Z-score of 1.4. So there's the ones place, the 10th decimal place, and here's the 100th decimal place, 1.40. And that coincides with a value of 0.9192. So this area under the curve, this shaded gray area, is 0.9192. If I go back to my slides here, what you can see that I've calculated on my whiteboard here is I have my value of 1.40 for Z, and I've drawn a line here on my standard normal distribution. To the left, this is 0.9192, or 91.92% of all observed cases. So that's the percentage that falls below a score of 121. To figure out the opposite, to figure out the percentage of cases or the percentage of scores that fall above 121, what we need to do is subtract 0.9192 from 1. Because as I said, this entire area under the curve is 100%. So we're simply taking 100%, subtracting 91.92%, and then that remainder is the area to the right of the Z-score. So in this case, 1 minus 0.9192 is 0.0808, or 8.08%. So to solve part 1, what percentage of scores fall above 121? That would be 8.08%. So let's do this for the second part. For the percentage of scores that fall above a value of 105. So here on my whiteboard, I've solved for Z. I did 105 minus 100 to get 5 in my numerator, divided that by 15, rounded to my 100th place, I have 0.33. That is my Z-score. I've even plotted it here on my standard normal distribution. I'm going to exit out of PowerPoint, go back here to my Z-score lookup table, and now I'm going to find 0.33. So let's see, we have 0.0. Here in this row, we have 0.3, and then we want to find the other 3 in the hundredths decimal place, and here we are. So a Z-score of 0.33 is associated with 0.6293. So this 0.6293 is the percentage of the area under the curve to the left of the Z-score. So in other words, it's 62.93% of all cases fall to the left. Going back to my PowerPoint. Here we can see on my standard normal distribution curve, I have plotted this Z-score of 0.33. I have identified that the area under the curve to the left of this value is 0.6293 or 62.93%. And then to figure out the area to the right of the Z-score, that percentage of cases or scores that fall above 105, all I simply do is I take my 0.6293, subtract that from 1. So 1 minus 0.6293 is 0.3707. Another way to think about this is if this entire curve is 100%, I take 100%, I subtract 62.93%, and I get 37.07%. So in the answer to this question, what percentage of scores fall above a 105? That is going to be 37.07%. And that's the exercise. Thanks so much for watching.